SAT Math Lesson 6. All right, so now we move on to solving linear inequalities. This again is Heart of Algebra 2 and Heart of Algebra 6. So first, let's talk about what an inequality is. Real quickly, an inequality is basically a relation which makes a non-equal comparison between two numbers or an algebraic expression. So an example of what an inequality would be is something like 3 is less than, 6. All right. But you also may see it as 3x minus 1 is greater than 4. So there are basically 4 simple inequality signs that you guys work with. You have the less than sign. Then you have greater than. Then you have less than or equal to. Then you have greater than or equal to. Okay, so those are the 4 most common. Now, when we solve inequalities, right, you solve them exactly the same way as you solve an equation. But when you multiply or divide by a negative, you must flip the inequality sign. And what that means is I'm going to put 2 examples up here so we don't mix it up. The first one is negative 3x is greater than 12. If I go to solve for x here, I'm going to divide both sides by negative 3. When I divide by a negative, right, I must flip this inequality sign. I'm dividing by a negative. So that would become x is less than negative 4. A lot of people will mix it up that if I give you something like 4x is greater than negative 20 and I divide both sides by 4, you have to understand I don't flip the inequality sign here because I'm not dividing by a negative, right? Therefore, it would just be x is greater than negative 5. Here we flip, here we don't. Let's look at some examples here. So remember, an inequality sign, when we solve an inequality, you can have more than one answer. So you need to understand that. If 3p minus 2 is greater than or equal to 1, what is the least possible value of 3p plus 2? Okay, so when we solve this, 3p minus 2 is greater than or equal to 1. I'm going to go ahead, solve this. 3p is greater than or equal to 3. And when I divide by 3, p is greater than or equal to 1. Now, this goes back to one of those problems like we talked about before where there's 2 steps to it. One is solving the inequality, but the second part is answering the actual question, right? What is the least, right, possible value for 3p plus 2? Well, when this says p is greater than or equal to 1, right, that means 1 is the smallest solution to the inequality, right? So if 1 is the smallest solution to the inequality because all the other numbers are greater than or equal to 1, I'm going to plug 1 in there. 3 times 1 plus 2. 3 plus 2 would give me 5. Notice here that they do basically, give you the solution that you should get, but that's not what they're asking for, right? So keep that in mind. Make sure you read the entire problem. The next one, which of the following inequalities defines the solution set for the inequality 23 minus 6x is greater than or equal to 5. So 23 minus 6x is greater than or equal to 5. First step, always get rid of things by addition or subtraction first. Negative 6x is greater than or equal to negative 18. Now I can go ahead, divide by negative 6. Now remember, when I divide by a negative, since I'm dividing by a negative, I have to flip that inequality sign to be less than or equal to, and a negative divided by a negative is a positive 3. So which inequality matches up with that, right? First off, that's negative 3. That's greater than or equal to 3, which is a trick because If you notice, it's the first, it comes before the actual answer, right? That can't be it, and letter D ends up being the solution. Okay, next one. Which of the following is the set of all real numbers x such that x minus 3 is less than x minus 5? So we know we have to actually go and solve this. So when we go to solve this, look what happens, right? I subtract x, I add 3, and we get no more x's left. Those eliminate. So we end up with 0 is less than negative 2. 5 plus 3 is negative 2. Now, what happens here, right, is that's a false statement at the end, right? And I have no variable to solve for. So what happens is this has no solution. And if you have no solution, that would represent the empty set. All right? So you have to understand that. Now, example 4. This is actually a absolute value inequality. And the only reason I put this in here is to show you how to work backwards from the answer. So these are going to be tough for you. If you remember how to solve them, great. If you don't, here's what I recommend on these type of problems when you get there and you don't understand them. It says, if the absolute value of 5 minus 2x is greater than 5, which of the following is a possible value of x? Well, all I'm going to do is plug all of these values in to see which one makes that true. So I'm going to multiply these in my head, right? So when I plug an x value in, 2 times that x value gives you what? So it would be the absolute value of 5 minus 2 times 2 is 4. Is that going to be greater than 5? Well, the absolute value of 1 is 1. Is that greater than 5? No. 3. If you think about it, it's going to give you the absolute value of 5 minus 6, which would give you the absolute value of negative 1, which is 1. Is 1 greater than 5? No. But then as you go along, you'll see when I plug 4 in there, right? Is the absolute value of 5 minus 8 going to be greater than 5? Well, that's going to give you negative 3. The absolute value of negative 3 is 3. Is 3 greater than 5? No. Now, when I plug 5 in there, that becomes 0, right? Because 5 minus 10 is, or sorry, no, it doesn't, sorry. Oops. So absolute value of 5 minus 10 will give you negative 5. Is that greater than 5? Is 5 greater than 5? No, that doesn't work. So now when I do the last one, the absolute value of 5 minus 12, right? That would give me the absolute value of negative 7, which is 7. Is that greater than 5? Yes. So therefore, 6 is the only value that makes that true. The next one, same exact story, right? Now we have a quadratic inequality, okay? Now, it says, if x squared minus 3 is less than or equal to 13, what is the greatest real value that x can have? Well, if I look, just by plugging these numbers in, 10 squared is 100. Is 100 minus 3 going to be less than or equal to 13? No. If I do the next one, 5 squared is 25. Is 25 minus 3 going to be less than or equal to 13? No. How about 4? And remember, they say, what's the greatest real value that x can be? So I'm going to start with the highest and work down. So 4 squared is 16. Is 16 minus 3 going to be less than or equal to 13? Well, 13 is equal to 13, so that would actually work because it can also be equal to, right? Now, 3 would be another one that works, and 0 would work, but you have to understand it's asking for what's the greatest real value of x can be. The next one, following figure below represents a solution set for which of the following inequalities? So when I read this, it's saying all my x values are to the right of negative 2, therefore they're greater than or equal to negative 2. Since that's a solid dot, it's also equal to, right? Now, Probably the easiest way to approach this is to actually just go and solve each one. All right. So here, if you're good at solving, you know you're going to subtract x. So you'd get negative 3x subtract negative 12 is less than negative 14, right? Is that going to work out? No. Here, subtract 2x, I get 2x. Then add the 2 is greater than or equal to negative 1. Is that going to work out? No. Right? I know this one's not going to work out because I subtract x, bring that over. That's not going to work. So now, subtract 5x from both sides. 3x minus 5x is negative 2x. Add the 1 is less than or equal to 3 plus 1 is 4. When I divide by negative 2, here I'm dividing by a negative, so I flip the inequality sign. 4 divided by negative 2 is negative 2. Here we have x is greater than or equal to negative 2, so letter J. You should check the last one to make sure, but due to video time, I'm just going to let you know it's J. And the last example. If 5 times the number x is subtracted from 15, the result is negative. For which of the following gives the possible values for x? So there's a lot of translation that has to go on here. And the tricky part is two things. One, this part here. 5 times the number, which is 5x, is subtracted from 15. So the order I have to write this is very, important. So I'm subtracting this from 15. So I'm going to start with 15 and I'm subtracting the 5x from it. The second tough part here is it says the result is negative. It doesn't tell me what it's greater than or less than, right? All I know is a negative number means it's less than 0, right? So here I'm going to translate the result is negative, meaning all the numbers it could be are less than 0, because any number less than 0 is going to be negative. So now I'm going to go ahead, subtract 15 from both sides and solve this inequality. Don't forget to bring down your negative 5x is less than negative 15. Divide by negative 5. X is greater than, I have to flip the inequality here. Negative 15 divided by negative 5 is 3. And if x is greater than 3, that would be letter B. Okay, it's a tough problem, but if you know your wording and how to set up the algebraic inequality, you should be okay. All right, go ahead, do the practice quiz and see how you do.